Good morning, everybody. Hope you had a great night and a great afternoon yesterday, and hope all your geometry homework was completed. And I know there's probably a couple of challenging problems on there, but I'll definitely go over some more of this when I return on Thursday. But today we're going to be looking at 7.6. This is circles, sectors, and segments. So circles, sectors, and segments. A couple formulas to get down. This is actually all related to circles today. And just think through these formulas and you should be good to go today. All right, so the first slide I have here is just kind of illustrating what we talked about yesterday with regular polygons inscribed, or you could say a circle is circumscribed about these regular polygons. You see the first one here is a triangle, and then we have a square, and then we have a pentagon, and then we keep going up, a hexagon, and so on and so forth. And you see that there's still always a radius, and there's always an apothem. But look what's interesting about the radius of all of these different circles and all of these different polygons. They're all the same. This the radius is going to be approximately the same no matter where you're at in this particular circle. But you can see that the apothem gets a little bit longer. So it kind of shows us a little illustration here when it comes to changing that formula for the area of a polygon, the 1/2 AP. And we're going to change that, and it's actually going to develop into the area of a circle. So a couple things here you want to get down, just some information here. As the number of sides increases, the length of the apothem approaches the length of the circle's radius. So in those pictures we had on the previous slide, if you keep getting bigger polygons, meaning you have more sides to them, as you approach an infinite amount of sides, you're actually going to end up with a circle, and the radius is going to be equal to the length of the apothem once you make it to a circle. The second statement here, a polygon's perimeter approaches the circle's circumference. Same idea, as you get more sides to the polygon, the perimeter is going to get closer and closer to measure the same as the circumference of the circle. And then the area of a polygon approaches the area of a circle. So in all those pictures that we had on the previous slide, if you keep getting more polygons or more sides to each polygon, you're eventually going to make a circle. That's the idea of what it's expressing and talking about. Okay, so here's the equation, and again, it's kind of out of whack the way it's being displayed. The area of an n-gon is 1/2 AP, and that's the formula that we had yesterday. And then we also know that the area, if that's true, that the area of a circle is going to be equal to 1/2 the radius times the circumference. That formula is developed because of the circumference. We know that the circumference is 2 pi r, so we develop that and we get area equals 1/2 r, which is the radius, times 2 pi r. So you guys can see with some basic math here, the 1/2 and the 2 are going to cancel, and then if you say r times r, you're going to get r squared. And that's how we know that the equation of the area of a circle is actually equal to pi r squared. That's how we develop it. Now this is the formula. Pi r squared is the one that you want to have written down. Most of you already know it, but if you don't, make sure you write it down. The area of a circle is equal to pi r squared. But now you can actually see how they develop it. It's pretty cool how they develop it with the previous formula that we had on the previous lesson. Area equals 1/2 AP. So there it is, right there. Area of a circle is pi r squared. All right, the area of a circle is pi times the square of the radius. That's the theorem that we have to state in order to use the formula. So you see the formula here, area is equal to 1/2 pi r squared. Again, you'll have that written down. So here's some basic problems here. Find the area, circumference in the area of a circle whose diameter is 10. Well, careful on this one. It says diameter, right? So we know that the formulas that we're using don't use diameter. They often use radius. So you just half that, and it gives you 5. And then we have the circumference. Again, if you don't have the circumference formula written down, circumference is equal to 2 pi r. Make sure you have that written down somewhere. Circumference is 2 pi r. Since the radius is 5 here, plug it in, multiply it, you get 10 pi. You can go ahead and multiply that out if you'd like to. 10 pi meters is a sufficient answer. But if you want to multiply it out, 3.14 times 10, we'll get 31.4 meters. Area of that same circle is pi r squared. The radius was 5, so we square it. And we're going to get 25 pi. That answer is sufficient. If you want to calculate it out, feel free to. 25 times 3.14 will give you approximately 78.5. So the two formulas that you got to have written down at this point are circumference, which is 2 pi r, and area, which is pi r squared. Both are related to a circle. All right. Well, central angle, we talked about this yesterday. The central angle is the angle formed between two radii, and you guys can see in the picture on the screen here. Here you have AB, which is a radius. Here you have BC, which is a radius. So this angle right here is called the central angle. We usually use the Greek letter delta. This is D, the symbol that's always used for the measure of an angle. This angle right here is just a 0 with a line drawn through it. That's the symbol delta. I'm sorry, theta, not delta, theta. So whenever I say theta, that's what it's referring to, that Greek letter there. The central angle of a circle is the angle whose vertex is the center of the circle and whose sides contain the radii of the circle. That's what we just got through talking about. All right, a sector. What you guys see shaded in blue on the screen on this picture that you see is the sector. I like to think of a sector as like a piece of a pie or a slice of pizza. How do I find the area of that shape? Well, you guys remember we talked about this last week. There's certain shapes that we don't know the formula for, so we have to use calculus in order to figure that out. But the ones that we're talking about in geometry, we all have formulas for them. And this is a shape that we usually don't use or find the area of, but we will in this particular lesson. So I'm really asking for what's the area of the piece of that pie, or the blue shaded area. And there's a formula that can be used here that's actually very intriguing, and we'll get to it in just a second. Let's go ahead and define a segment. A segment is a segment of a circle is a region bound by a chord and its intercepted arc. This section that you guys see here shaded in, that I'm coloring in right here, this is referred to as a segment. So you're going to have to find the area of a segment as well as find the area of a sector. So we're going to talk about how to do that. A practical example of how this is used is just in any kind of pie chart. We see this in math all the time. You see this in business and in banking and accounting, all kinds of different things you can see a pie chart in. And here's an example of one, but now you can get an idea of a practical use of the area of a sector, because you can actually find the area of these shapes and actually draw them properly on graph paper or on regular sheets of paper when it comes to a pie chart. So here it is. This is very important. The ratio of the area of a sector to the area of the circle is the same as the ratio of the central angle to the measure of a circle. So you guys see the area of a sector right here is in the top part. Then you have area of a circle is going to be proportional to the central angle divided by 360. Easy way to remember that is sectors have central angles, and then circles have 360 degrees. So that's the way I remember it, and you may want to do the same there. But that's just a ratio. The theorem that you want to write down for the area of a sector is written here. It's difficult to see, so I'll go ahead and write it at the top of the screen here. Area of a sector, that's what you need to write down with this. It's equal to theta over 360. Theta, again, is the central angle. And then we need to multiply that times pi r squared, which would be the area of the circle. So you take the central angle, theta, divided by 360, and then you just multiply that times the area of a circle, and that would tell us the area of the sector. To find the area of a segment of a circle, find the area of the related sector, and then subtract the area of the isosceles triangle. So let's take a look at an example here, and we'll see how this works. Find the area of the sector and the segment. Again, remember, sector is a piece of the pie. So I'm looking for the whole thing. I'll color it in here so we can look at it. I'm looking for all of the area of this shaded portion here. That's the sector. Then it says the segment. The segment would be this portion right here. So you guys can see on the screen, I'm coloring it in there for you so you can see exactly what it's talking about. So let's go ahead and figure this out. We have a formula for the area of a sector, and make sure you have this written down, guys. It's extremely important. Let me back up. I'll do it manually here. We have the area is equal to theta over 360 times pi r squared. So let's look at our picture. Theta is the measure of the central angle. Right there, I'm circling it there. It's 84. So in my formula, all I have to do is say 84 divided by 360. You can use your fraction button on your calculator, or you can actually punch that in exactly as it states it, 84 divided by 360. You'll get a decimal. That's perfectly fine. And then I need to multiply that times pi, and then times the radius squared. The radius of my circle here is 3. So I would need to say 3 squared. You just simplify that out, guys, and that'll give you the area of that sector, area of the piece of the pie there. It's not super hard. It's actually quite simple, as long as you remember your formula. Got to remember that, okay? All right, so we need to figure out the segment now. Okay, the segment is the small portion, the portion made by the chord PR, or line segment PR. So in order to figure that out, I have the area of the sector. I'll go ahead and advance the slides here so we can see what answer we get. It'll look like the area, it's kind of hard to see with my writing on here. I think it's about 6.6. 6.6, I'll put it up here on the top so we can reference it. 6.6 centimeters squared is the area of the sector, or the piece of the pie. Now to figure out the area of the segment, you guys can look on your picture here. This is the segment here. What I do is I take the area of the whole piece of the pie, which we call the sector, and I subtract from that the area of my isosceles triangle, and that will give me the answer that I'm trying to achieve. And they figure out that the area of this triangle is 2 square roots of 5. I believe we have a formula that we've learned for the area of a isosceles triangle. So that's probably what you want to reference in order to get that answer, 2 square roots of 5. So then at that point, you just subtract the area of the sector from the area of the triangle from the area of the sector. The 21 pi over 30, that's what you would get for the area of the sector, minus 2 square roots of 5, and when you do so, you get approximately 2.1. Gonna have to be careful punching all this in on your calculator. Take your time. If you have trouble figuring it out, you can always ask a classmate how to figure it out. And what I mean by that is how to punch it in the calculator. If you still can't figure it out, again, I'll help you out when I return on Thursday in order to be able to be successful on this concept. That's it, guys. That's the whole lesson today. Again, just a quick review. The formulas that you want to have written down is the area of a sector is equal to theta over 360 times pi r squared. And then to find the area of a segment, you find the area of the sector, and then you subtract the area of the triangle, and that'll give you the area of that sector. I think you'll be able to handle this. It's not super hard. You just have to really know the difference between sectors and segments. If you can remember that and remember the formulas that you'll have written down, you should do pretty well on the lesson. Again, tonight I'm going to go ahead and assign numbers 1 through 20. I want you guys to practice these concepts. And when I return on Thursday, we'll be doing a little bit of review in order to make sure you guys understand this so that we can be well prepared for the upcoming test. Hope you guys have an awesome day today. Good luck to each ball player tonight at Wilmington. You guys play hard, do your best, and get that victory that we need. And look forward to seeing you guys in just a couple of days.